It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Very good evening, Satish. Am I audible? Very good, thank you. Good evening. So the people are joining, okay. So it is same as yesterday's. This is the last session because the day after tomorrow you have an exam. In the second half of the month, maybe I'll plan few more sessions little later. But I mean, for TSSN, PDCL, whatever, maybe you have the exams. We'll continue this series. But before your exam, which is going to happen on this Sunday, today is the last session. Tomorrow, I may take some session, strategy session, just one day before your exam, how you need to stay motivated. These things we may be discussing tomorrow. Okay, fine. Right. Chalo, we'll continue with the questions from network analysis and few questions from digital circuits today. So if you want to take, if you want to go for my classes, if you want to see my free classes on an academy, just scan this QR code. You'll get every single free class of mine on an academy platform, which are completely free for you. Okay, so combat exam is going to happen on this Sunday, which is based on your ranking. You will be getting the scholarship up to 90% on your what we call an academy subscription. So July 17th, 12 p.m. you have this exam. That is this Sunday. 20 questions and 60 minutes for across all the branches. You can use the code to enroll to the examination. Okay, that examination link will be available in the video description. The new batches have been started already on the plus for both EC electrical students. Analog circuits I have started yesterday, and also signals are also started. So these are the new batches going on right now. So let's move further questions without any further delay. एक दो क्वेश्चंस आसान भी हो सकते. Okay, so don't think every single question will be like this. So the first question today is from digital, and of course it is very easy. Right. So here I cannot discuss any doubts because this is not the platform. You could have been asked in my plus class here or in the special class. On platform, anytime you can come in the last 10 minutes, I can help you with any kind of doubts because there it can be better to clear. What happens today? No strength. In the app also it is not showing live. Okay. So what is the right answer, guys? This is not a difficult one at all. Okay. So here, what is your Qn plus 1 Q bar? Okay. So it is a toggling condition. Whenever it toggles, your output frequency is always equal to f clock by 2, because if the clock is like this, okay, your output will toggle on every clock. Okay, so its time period will be doubled, frequency will be half of the input. So 10 diya to 5. Okay, right. Let's move for the next. Next question. Try to answer this question. Why very less number of students today? Every day generally more number of students used to come. Option C, right answer. Don't know here what today no students. Sudden drop. Okay. So when you connect in a SR flip-flop, one inverter is connected, it will work like a D flip-flop, right? This is a very good question. Ready? Shafi, you can, I'll try to send it in what we call Unacademy community. You can follow me on Unacademy community, I'll share. Okay. Option A. So I'll tell you logic. At time t equal to infinity, the network will be in steady state. At steady state, the capacitor acts as open circuit. So this is the voltage V, and the capacitor acts as an open circuit, and you have a resistor. Because there is an open circuit, no current will flow here. If no current will flow here, there is no drop across the resistor. Okay. 1 minute. Because there is a resistor. Okay, it is a DC. Okay, fine. At steady state, you get here V by 2 and V by 2. 1 minute. If you take V by 2 and V by 2, it will be wrong here. Why? Because if you take V by 2, the current here will be V by 2R. That current को तो कोई पाती नहीं है. It should flow like this. In that case, if it comes, then capacitor will not be in steady state. Suppose if you connect here a source, and if you assume the current is flowing like this, it will completely discharge. So it should be V. What is that? The steady state voltage across the capacitor C2 will be 0. Okay, if you have the same circuit like this, C1, C2 and V, in this case, yes, it will be V by 2, V by 2. If you want, I can prove why, what we call Laplace transform. Because both the capacitors are same, 1 by SC, this is R, and 1 by SC, and this is your V by S. What do you want? You need the voltage across C2 voltage. What is V2 of S, or what is V1 of S? V1 is equal to V by S into 1 by SC by 1 by SC plus R parallel with 1 by SC, R into 1 by SC by R plus 1 by SC. That will give you V by, okay, you take SC here, you take SC cancels, okay, R plus 1 by SC, 1 minute, 1 by SC by 1 plus SCR by R plus, okay, this will come. Take LCM, 1 plus SCR plus SCR, okay, in the denominator, in the numerator, into V by S into 1 by SC. 1 by SC, 1 by SC will cancels. V into 1 plus SCR by 1 plus 2 times SCR. Okay, you take SCR common V into S plus 1 by RC. Okay, RC common ले रहा हूँ मैंने. V into by S plus okay, this is what you are getting finally. Just a moment. V by 2 into S by S plus 1 by 2 RC, whatever may be the constant, plus V into 1 by RC by S plus 1 by 2 RC. Okay, here it is an exponentially decaying signal, it will become 0. Okay, so here it will be exponentially decaying signal multiplied with S. That will also become 0. 1 minute please. I want to just cross check it. D by dt of e power minus t. Both the cases it will exponentially decay and becomes 0. Yeah. Okay, let's proceed further before that. One minute. Yeah, it is a DC only. What is the problem? You can find the final value theorem when s equal to 0, s limit s tends to infinity, s into x of s. Just one moment. Okay, we'll proceed further. I'll cross check it. Okay, try this question. I missed something. वहाँ कहाँ पे? It is a long story. Where I missed 1 by s? Cosmos. Okay. Okay, you just keep this aside. Calculation I haven't done. Okay. Don't conclude as V also. Okay. Somehow some 1 by s something I missed it. Where I missed it? Third step. Okay, okay. Here by s छोड़ दिया मैंने. ठीक है, कैलकुलेट करके चेक करो. चलो नेक्स्ट क्वेश्चन. I missed one yes here, yeah. Okay, fine. Try this question. Try this. Okay. Option D. Wrong answer. Option C is the right answer. Okay. Option C is the right answer. Okay. Fine. Listen here. I'll tell you the trick here. Whenever you see R minus jx and R plus jx format, इसके लिए थोड़ा सा trick है. Okay. What is the overall admittance y equal to 1 by R minus jx plus 1 by R plus jx, right? You can say z equal to R minus jx into R plus jx by R minus jx z1 z2 by z1 plus z2. ठीक है. So this will give me a square a plus b into a plus jb into a minus jb is a square plus b square by 2r. Okay, don't do this when you don't have both are equal. Here दोनों equal है ना, 1 1 minus j plus j. इस केस में केवल applicable. Okay, so r square plus x square and 2r. So what is your z is equal to here? Only real part will come, imaginary part will be cancelled out. So r square plus x square, 1 square, reactance 1 square by 2 into 1, that will give me 2 by 2 1. So this total network is equivalent to 1 watt. So here you applied the 10 volts. Okay, so what is the active power is 10 square by 100. Reactive power is 0. You solve this question by different methods, phasor diagram analysis. This by this will give you the current. This by this will 10 by 1 plus j will give you this current. इसमें real निकालो, imaginary करो, total complex power को P plus JQ और P minus JQ कर सकते हो. बहुत लंबे ज़्यादा time लगेगा, उतना करना ही नहीं चाहिए. Okay. So what is the right answer? Option A, 100 watt and 0 reactive power. Right. Let's move for the next question. Next question. This is the similar question. Okay, it may take time. Let's move for other question and come back. This question, I hope you people can do it. So give it a try. Okay. You SK, don't worry about those people here. वो तो आते जाते. Okay. We just worry about our work. That's all. Next question. Option C or option D? Megahertz. C. ठीक है. Right. So the conversion time of 12-bit counter type ADC with 1 megahertz clock. So what is the time period of the clock? Time period of the clock is equal to 1 megahertz, means 1 microsecond. The total conversion time in counter type ADC is 2 power n minus 1 into time period of the clock. Okay, he is given counter type ADC. So 2 power 12 minus 1 microsecond. 2 power 10 is 1 kb, 2 power 11 2 kb, 2 power 12 4 kb, 4096 minus 1 4095 microseconds. Okay, 4095 microseconds can be written as 4.095 milliseconds. So option B is the right answer. Okay, right. Option C nahi bhai, option B, option B. Okay, is it clear? Can I proceed to the further to the next question? Right. This is also a little tricky or good question. Very good, very good, very good. Option D, right answer. Okay, here you can observe here by KVL the voltage across the inductor equal to the voltage DC plus Vm sine omega t is equal to VL. Okay, but what is VL? L dIL by dt. Okay, equal to Vd plus Vd is Vdc plus sine omega t. So can I say like this? Vdc by L, Vm by L sine omega t equal to dIL by dt. If you apply integration both the sides, you get VDC by L into integration of constant t. What is the integration of cos? It will be sine. So by omega L sine ka cos, cos ka sine ka minus cos omega t. Some constant will come equal to your I. Okay. So you see this equation, you have some sort of ramp signal and also one cosinusoidal signal. Unbounded system it is going to. Okay. So this is the your answer, option D. Chalo, next. These are not much difficult questions. तो आसान है. Read this. Okay. Piyush दिया option A. So in the network, linear network, when 10 volts is applied to a port 1, the current through the 4 ampere is the port 2 short circuited. इसमें थोड़ा सा ज़्यादा time दिया क्यों? I have given sufficient time. 2 minutes दे दिया मैंने. It is the same question given in GATE 2015. Okay. In this paper, I have seen many GATE previous questions. GATE 2015 पे आया ये वाला question, right? So we can solve this question with the help of ABCD parameters in a linear two-port network. When V1 is applied, okay, the current V1 equal to 10. The current flows, a current of 4 amperes flows through the uh, port 2, that is I2 equal to 4 with V2 equal to 0. Okay, so keep this information with you. What is V1? A V2 minus B I2. Okay, so now listen carefully. When V2 equal to 0, V2 equal to 0, what is V1 by I2? V1 by minus I2 equal to B. Okay. He has not given the direction. If it is entering, flows through port 2. Okay, let us assume this is the current given by examiner. Okay, just for assumption, 4 amperes. Okay, so B is equal to 10 by 4. Okay, I2 is equal to minus I2 equal to 4, 2.5. One information we obtain. Next, when 5 volt is applied at port A, V1 equal to 5. Okay, the current of through 1 ohm resistor connected at the port B. Otherwise, 1 minute. Leave all this stuff. Simply I'll do it. With the help of Thevenins, we can do. Okay. First thing, when V1 equal to 10, okay, the load current is equal to 4. Okay, fine. Right. V2 equal to 0. Let us assume there is some Thevenin's voltage VTH. I don't know RTH. Okay. Now, if you short circuit this, what is the current? Examiner has given 4 amperes. So VTH by RTH. One information we obtained, VTH equal to 4 times RTH. First information. Next. Second information is when V1 is equal to how much? When V1 equal to 5, the current of 1.25 will flow through the resistance of 1 ohm. So here same input. Now input to arda kiya. He said linear network. Assume it is a reciprocal network also, nothing specified. So VTH will be divided with 2. Now what is the RTH? Same RTH, but now the resistance is 1 ohm. What is the current you are getting is 1.25. So VTH by 2 by RTH plus 1 equal to 1.25. So what is VTH? By RTH plus 1, you just take to 2 to the other side, 2.5. What is your VTH? 2.5 RTH plus 2 into 2.5, 5. But you know your VTH is equal to 4 times RTH. 4 RTH equal to 2.5 RTH plus 5. 1.5 RTH equal to 5. What is RTH? 5 by 1.5. What is VTH now? Okay, 4 times RTH. So 20 by 1.5. 40 by 3. 10 by 3. Okay. Now the last point. When 3 volts is applied at the port, okay, 2 ohm resistance is connected. Okay. What is the current he is asking? Might be. Okay. Now, Vn equal to 3, okay, R equal to 2, what is the current I? Now VTH will be 0.3 times, okay, 40 by 3, that will be 4. RTH already you know 10 by 3. And then if you connect a resistance of 2 ohms, what is the current? 4 by 10 by 3 plus 2. 4 3 is 12 by 15. Okay, 12 by 15 means 4 by 5. I'm getting 0.8. 0.54 आना चाहिए यार. कुछ कैलकुलेशन गलत नहीं किया ना. Resistance is 10 by 3 plus 2. RTH will be it is 16 na? Then 1 minute. It will be 12 by 16. 3/4 0.75 भी नहीं है. 1 minute. आज क्या हुआ यार? 0.54 is the right answer. मैं तो भी कैलकुलेट किया. Just a moment. VTH, ITH, first current कितना? 4 amperes is given. VT by RTH equal to 4, VTH equal to 4 RTH, correct. Second case में 0.25. VTH will be divided with 2. VTH by 2, ये तो 1. One small calculation error. I am very sorry. I'm very bad at calculation. Here, you just multiply. This will be 2.5. 2.5. So 2.5. RTH equal to 5 by 3. It is 5 by 3. RTH 5 by 3. VTH equal to 20 by 3. RTH is 5 by 3, VTH is 4 times 20 by 3. Here, when input is 3 times 3, that is 0.3 times 10. Na? So VTH will be 0.3 times, that is 3 by 10 into 20 by 3. That will give you VTH equal to 2 here. Okay, and RTH is 5 by 3. So current is 2 by 5 by 3 plus 2. That will give you 2 3 6 by 5 plus 6 11. That will give you 0.54. Bus. Okay, is it clear, everybody? This is nothing great in this question here. मैं तो zoom out करके दिखा रहा हूँ. Firstly, input equal to 10, short circuit current दिया. So VTH by RTH I obtained. Then input is divided with 2. Then it is VTH by 2, RTH, and 1 ohm is connected. He has given the current. Now this voltage by total resistance will give you 1.25. From that I obtained the relation for the VTH. Because the input is divided by 2, I reduced the VTH also 2, but I kept the RTH as it is. So that will give me my RTH equal to 5. Solving this equation, I get RTH 5 by 3, VTH 20 by 3. Now input is 3, then VTH will be, normally for 10 it is 20 by 3. If it is 3, it should be multiplied with 3 by 10. That will give you the VTH. Now 2, 5 by 3, and 2, what is the current? Fine. Let's move for the next question. Next question. Okay. So guys, give your exam in the best possible way. As you people requested, I am able to take every single day class for you. Today I was a little hectic yesterday and today also because of my new plus course. Already I took 3 to 5, 6 to 8, 9 to 10, 3 consecutive classes. This is the fourth session. Okay, that's why I'm doing some calculation mistakes also. Yesterday also, but because your exam is on Sunday, it will not, your days will not come back. That's why even it is little stress, I'm taking it to today. Okay, tomorrow also I'll plan one session. Just I want to give you some examination tips, not this technical. Just before the exam, I'll give you some tips. Maybe tomorrow evening, 4 p.m. or 5 p.m. Session is already created. Mostly I'll take it 4 p.m. If I have some work, I'll take it at 5 p.m. Okay. Yes, K, what happened? You're asking this question? Because for 10, okay, what is the relation between 10 and 3? If you multiply 10 with, okay, 3 by 10, you will get 3. The same way you multiply your VTH with 3 by 10. Okay, because your VTH is reduced by 10 and 3. What is the relation? It is reduced by 0.3 times. So you can say 0.3 times the original VTH which you get it for 10. Understand? Right. This question तो आसान है भाई. क्या? Here plus J4 नहीं minus J4 because ये तो capacitor है ना, impossible to get plus J4. So what is the X equivalent? Overall admittance is equal to, okay, sum of individual admittances. Okay, नहीं है तो you can do J2 into minus J4 by J2 minus J4. What is the answer? ठीक है, J square equal to minus 1, minus into minus plus 1. Okay, J square is minus 1, minus into minus plus, so it will be root normal 8 by minus J2, that is plus J4, because denominator में minus, numerator it will be plus J4. So what is your Z equivalent? 6 plus J4. Okay, power factor is equal to, okay, R by Z. R is 6 by root of, okay, otherwise see here, this is real part is 6, reactive part is 4, and this is the mod Z, which is root of 6 square plus 4 square. What is the mod Z? 36 plus 16, 46 root 52, 2 root 13. So power factor is cos phi. Cos phi equal to R by Z. 6 by 2 root 13. That will be 3 by root 13. Okay, because it is plus, you should take log. Okay, fine. I hope it is clear. Right. Next. So try this question here. It's not very difficult. I hope you can do. The reduced instance matrix of the graph shown. He is just asking the order of the matrix. Right? Originally, yeah. Option. अरे यार देख के दे दो आंसर. Please check your answer. This is a very straight away question यार. SK दिया D. अरे यार I am sorry. Number of nodes 4. Number of branches 1, 2, 3, 4, 5, 6. Okay. What is the augmented incidence matrix? Okay, he's not saying tie set or something. It is N by B. What is the reduced instance matrix is N minus 1 by B. That is 3 by 6. Okay, this is a complete incidence. This one reduced incidence. Okay, if you need a tie set matrix, B minus N plus 1 into B. Okay, chalo, let's move. I need some water. Try this question. Okay. So the transfer function है तो आसान क्वेश्चन है यार 1 by SC 1. Okay. V2 by V1 ना voltage division principle, this by total. Okay. That will give you 1 by S plus 1. Right. This impedance by total impedance will give you the voltage transfer function. Right. Next question. Okay. Time up. What is the parameter? A, ABCD parameter पे. Okay. So what is parameter A? V1 equal to A V2 minus B I2. इसमें I2 को 0 करो. V1 by V2 is your A at I2 equal to 0. So if you make I2 0, okay, this voltage is equal to V2 and V1 is equal to V2 means 1 is the answer. बस हो गया question. Right, very good. You can find the T parameters, Z parameters, all those stuff you can do, or you can do it as a cascade connection of this network with this network. You do by any method, you get the same answer, but only one parameter is required. Directly do like this. Okay. Next question. Yeah, actually, I have another session. So I'll wind up this session with this concluding question and this total series which we are going to through in the last 1 week. Okay. So all the sessions we covered as many questions as possible, all the PYQs possibly I am able to solve it for you guys. Give your best in the exam. Tomorrow I'll meet at 4 p.m. on Kreatryx channel. I'll come live. I'll give you some examination tips and I'll conclude the session. Okay. This is what we call the last session for this. Strobe input is used to avoid the transient states. If you have studied my digital class, I already told there. Okay, strobe signal is used to avoid the transient error. Okay, total delay should be, the time period of the clock should be always greater than n times TPD plus if you have any kind of strobe signal, you should include that. Or gates, strobe is some sort of gate or something. During the transient period, it will disable the counter. It will avoid the what we call decoding errors. Because in the ripple counter, there are transient states possible. Okay, so what is that 3 stage now? 3 into 25 plus 10, that will give you 75 plus 1, 85 nanoseconds. So your frequency should be 1 by 85 nanoseconds. Okay, let me do the calculation. Okay, Boni, in the second half of this month we can plan. 11.76 megahertz. Okay, that's all, guys. We can conclude for today. I think hardly 3 questions left. 4 questions. I'll at least give the answers and go so that it will not be a difficult thing for you. Here, 12 branches, b minus n plus 1 equal to L. L is how much? 8. B is 12. N I don't know, plus 1. So what is your N is? 9 minus 13 minus 8. 5 is the answer. 2 questions, just I'll quickly give it. Two-port network, what about Y parameters? You assume this as a admittance. Okay. So in that case, what about otherwise if you assume Z parameters, ZA plus ZC, 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 ZB plus ZC. Determinant of Z equal to 0, Y parameter does not exist. Or you say it is a pi network, YA plus YC. What about YC? It is short circuit na infinite. Last question. The lowest and highest critical frequencies are nothing but poles and zeros. For RC driving point, what is the lowest one is pole, highest one is zero. Starting with pole, ends with zero. So that's all for today, guys. Okay. So these are the questions I want to discuss with you. These are yesterday class questions. Chalo. So this is the new batch started on Unacademy, guys. All these are the benefits of Unacademy. You get the classes by top educators, top clearing sessions, study notes, test series सभी मिलेगा. आपको physical notes चाहिए तो one-to-one mentorship, strategy program, personalized guidance चाहिए तो you can go for the iconic subscription. Okay. So today is the last day to avail this offer, guys. You can use my code whenever you join Unacademy. You'll get the 10% discount on the subscription. Okay. Right. So that's all from my side. Okay, thank you very much for your time, guys. I need to run for my next session. I have some interview session is there. Okay, I hope these sessions are helpful for you guys. All the very best for your exam. Okay, let's crack it. See you. Okay, I want to hear a lot of good news from all you people. Okay, give your best. All the best. Okay, we'll continue also. I covered that Cosmos in network synthesis concept. It is there in YouTube and Plus also. Okay. Thank you all. Good night.